Hello? Am I live on the air? Am I live to the people of the internet? Let me close this because this is rude. Okay, it's rude to be unorganized and look unorganized for everybody out there. Okay, it's a little rude of me. Okay, I'll admit it. I'm not perfect. Neither are you. You're not perfect either. Okay, dude? So, yeah, you're not perfect either. Is everything up? Okay. Not quite. I need to use chat? Chatting version of this? Okay. Can hear myself. I'm a little quiet. Maybe I should increase my volume on this a lot, actually. Properties. How do I increase my volume a lot? Advanced audio properties. I can increase it even more, so let's keep talking, let's keep talking, let's keep talking. Let's increase it to 6 dB, maybe? 6 dBs, how does that sound? Is that any better? Maybe I should increase it even more, or maybe I should just put it up to my mouth more. Does that make it sound better? Okay, putting it up to my mouth more has made it sound better, but I should probably also just turn it up, I guess. Let's do 10 dBs, I guess. Okay, 10 dBs. This should sound pretty good. I have it kind of away from my mouth while I'm talking. Yes? Everything sounds good? I think so. Okay. Yeah. Seems good. Seems fine. Boom. Easy as pie. Um, view my channel. This, edit video. My thumbnail is uploaded, but it's not showing up. Tags. Okay. Tags have been added. Boom. We should be good now. Okay, so I know that in the title this says study with me, but we're gonna start off by meal prepping, okay? Because I need to meal prep. You might not need to, but I need to, obviously, okay? And I encourage you to meal prep if you haven't already. So I'm going to be making some rice. I have leftover rice that I will be turning into a meal for tomorrow morning because I get up at 5 a.m. to go to the gym. That's right. I'm better than you. It's kind of actually, yeah. Okay. Well, okay, hopefully my audio doesn't sound good. I don't care. Whatever. But yeah, that's right. I'm better than you. Guess what? I am. I'm just better. I am him, okay? Listen, in order to be successful as a person, you need to develop a god complex. That is the only way. It's the only way you can be successful. Trust me. Okay, you don't trust me? Why not? You should trust me. I'm obviously successful already. Okay, I'm obviously successful. Look at my crib. Look at my MTV crib. You think this isn't the crib of someone who's majorly successful? Try again. Try again. Freaking loser. Oh my god. Okay, so what are we doing? We're making rice. One. So here's the checklist. Here's the checklist of things that we're doing today, okay? Number one on the checklist, make rice. Number 2 on the checklist, meal prep for tomorrow. Number 3 on the checklist, read through physics and maybe even math if we're wild like that, but I don't think we'll do that. I think what we'll probably get through is chapter 2 and 3 of our physics textbook, which is what we need to get through. Yeah, number 4, do dishes. That's probably higher up. Bottom is physics, because once we're done with all this, then we're going to move to that, okay? And again, disclaimer, the only reason why I do these streams, okay, is so that I force myself to do the things that I don't want to do. Because if you just leave it up to me, I will let my life go into complete shambles. Okay? So what I have to do to force myself to do things is to make it a performance. Make it performance art. Oh, God. That's how I know I'm an artiste. I am an artiste! Because if my life is not but a performance, then what but is it? If my life is but not a performance, then but is it? So we're washing rice, right? You just... Quick tip for those of you who don't know how to wash rice, okay? This is my half Asian heritage coming out. Okay, listen, you don't need a fancy strainer, although it's a lot easier to wash rice with a strainer. And it's a lot easier to cook rice in a rice cooker. But does this kitchen look like it has enough space for a rice cooker? I didn't think so. Okay, so shut your mouth. Alright, but basically to wash rice, you just friggin... You put rice in a pot, fill it up with some coldish water, and then you just go through it by hand, kind of just, fibble it around, right? Fibble, that sounds like a word. Fibble it around a little bit. Maybe twice. I'm just gonna do it twice, because honestly, don't really care about washing my rice too much. It's not like I'm eating this food for flavor anyway. I'm eating this food for nutrition, purely nutrition-based purposes, okay? So, yeah. Wipe off your hand with a kitchen towel, of course. Then what else? Now we need water. Here's a little tip and trick for those of you out there who don't know how to make rice. If you don't know how to make rice, I'm sorry for you. Okay, I should have my stream pulled up. I do. Okay. Double check. Make sure everything's good. I can talk louder. Yeah, I can talk louder. Whatever. Okay. So, get out your Brita filter in that plastic container. Plastic is good for you. Hell yeah. Let's do it. BPAs? I need BPAs in my system. BPA much? BPA me up, please. Okay, so the trick I'm going to tell all of you is you stick your finger into the rice, right? And then you put your thumb. So you stick your finger into the rice, put your thumb, no. Stick your finger completely into the rice, and then put your thumb where the rice ends, like that, and then put it up and put your finger on top of the rice, and then wherever your thumb is, you just fill the water up to that point. It's not a foolproof plan, obviously, because if you have a really thin pot, you can have like that much rice, and then your finger goes all the way down, so you'd fill up. Actually, no. Oh, is it proportional? I think it might be proportional, but probably not perfectly proportional. But I think it might work, even if you have a really wide thing. Actually, it might be proportional. Actually, didn't even think of that. I added a little bit too much water, so I'm gonna pour a little bit out. I think this is good because this particular rice that I bought, it really doesn't need too much water to cook. But anyway, so now that we got that, cover that, turn it up on high. When it starts to boil, shut it lower. Turn it lower. When it starts to boil, turn it lower. Be real is going on. We're gonna take a nice little picture of the outside. For the morning. Yes, yes, yes. Yes, yes, yes. Yes, yes, yes. Okay. Um, what else? What else do we got to do? Message people back. That's another thing we gotta do. Okay, now let's prep the ingredients. Okay, so camera a little bit down. This is our cooking center. Watch this. Watch this. You think this is small? I agree with you, but watch this. Okay, you couldn't really see that. Watch this. That's right. It's folding. It's a folding table. You can fold it out, make it bigger if you want. So check the fridge out. Rice, leftover rice. We're gonna cook that. Um, we have some onions that we can make as well. So let's get our stove, our pan heated up a little bit, just a tiny bit, not too much. Okay, not too much. Um, and then this, we're gonna put our onions into this. Life hack, by the way. Look at this freezer. You see how bountiful everything is? But life hack, cut a lot of onions in one go and then freeze it. Okay? If you cut a lot of onions and then freeze it, then whenever you need onions, you just, bang it up a little bit, right? And then, boom, you got onions in your Ziploc frozen BPA filled bag. But listen, it's not like these are the years of my life where puberty is finishing up, and so the amount of excess random hormones in my system would actually have a meaningful impact on how I develop. No, no, no. Okay? These are also the times of my life where I'm broke, where I have no money. It's Mog on them. Mog on them. The broke boy Mog. Okay? Okay, so we want to heat this up. You can heat it up more. So we've got these, usually I like to buy the mixed veggies, but Target ran out of them. So we have these steam in bag cut green beans. We're going to be using the rest of them. And then tomorrow, hopefully we can buy some more frozen veggies. Hopefully they stock up on it. They've been out of stock for 2 or 3 days now. L much Target, L. Target L. But yeah. So we're going to fry up the onions first. The reason why I don't want the pan to be too hot is because if I have the pan that's really hot and I put the oil in, it's going to just burn the onions really quick. But, I want the pan to heat up. I don't want to be standing here for 20 years. Okay, so I think that's good enough. We're going to use avocado oil because it has a higher smoking point. And the whole point of that, you can use olive oil to cook, by the way. Just because olive oil smokes early does not mean that it's like going to be carcinogenic or toxic or bad to eat or anything like that. When olive oil can smoke, but something with the actual, like the molecules of the oil themselves, they still remain fine. I think olive oil, probably coconut oil is probably the healthiest oil you can use, but olive oil is still pretty good because it has a nice flavor. But yeah, you probably would rather want to cook with, I think, ghee. Coconut oil and ghee, I think, are the best things to cook with. But avocado oil is also pretty good. You don't want to use seed oils because they're high in, is it polyunsaturated fats? I think it is. I think it's poly, right? Because monounsaturated fats just have one chain that's not, or does it have two? If it has one chain, I can't remember. Let's Google real quick. Is olive is olive oil high in monounsaturated fat. Okay, it's so monounsaturated is the quote unquote good kind. It's the one that your body can break down better, handle better, blah blah blah. All sorts of food science reasons. I don't really know in particular, but yeah. So that one is good for you. But avocado oil is also pretty high in monounsaturated fats as well. So, but I think the best ones to eat. Jesus, I cannot break down this onion. Okay, there we go. Okay, I'm just gonna leave it like that for now and then cover it because the oil is quite splashing everywhere. I don't like that. I hate oil. My kitchen does not have ventilation, proper ventilation, so I have to turn on a fan to get a little bit more ventilation. But of course, the fan is not going to be enough. But it works. It works. I'm going to clean up the floor with a little bit of oil. Splash on the floor. Because listen, the way... Now here's a life hack, okay? Listen up. The way that you keep a proper living space, a proper living environment, is by not like cleaning it, once a month and then letting it go to hell and then repeating that process over and over, but it's by developing good habits for cleaning. I also just realized I should probably just edit this and say cooking first. Meal prepping first in the title. There we go. Boom. Boom. Move the top of that. Put all the excess water into the sink. Break up this chunk of onions that's frozen. Break it up a little bit more. Bing, bang, boom. Would you look at that? Perfect little concoction. Okay. Cover that up. Let it steam for a little bit more. We're going to add the green beans soon. I know you're clamoring at your seats. Paul, when are you going to add in the green beans? I know. We're going to add it in soon. Like 2 minutes from now or something. I should put this up. Now you might ask, what have I been up to today? You probably won't ask, but is there any use in talking about... Okay, the whole reason why I'm streaming is so I can force myself to do positive things. I don't think me talking about what I did in the day is going to help at all, because I already did it. I think probably me talking about what I want to do this week probably will help. Maybe? Question mark? That's a hunch that I have, though. It's not absolute set in stone. Alright, we're going to add in the green beans now. I know all you green bean boys were waiting for this moment. Oh god, when is he going to add in the green beans? He needs vegetables. Vegetables are good. Onions aren't enough. I know. Okay, you think I don't know that? You think I was born yesterday? I wasn't. Shit, the rice is overflowing. I hate when that happens, because cleaning that up is kind of a mess, but yes. Okay, there we go. Remove the lid off of the pot. Turn down the heat a little bit, because you don't want it to burn. It's probably still going to burn the bottom of the pan, though. I don't know why, but recently when I've been making rice, the bottom of the pan just always gets burned. I think it's the particular rice that I'm using. It's just like, it's a cheaper rice, so it's... I don't know, it's more clumped up. I don't know. I don't know rice science. I don't know what helps with making better rice, okay? Guilty as charged. But yes. Next thing we're going to add in is this rice, okay? I'm going to break it up a little bit. Okay, I think that's broken up enough. Put all this other stuff into this bowl. Let it soak a little bit, because we're going to wash the dishes soon too. Right after we're finished meal prepping, we're going to wash dishes as well, because that's the most efficient thing to do, okay? Don't be lazy. Just do it immediately after, okay? You cook, then you clean, okay? You don't have to do it during. I don't like to do it during because then you get like dish soap on your hands. I don't want soap going into my food, you know. I'd rather dirty bacteria go into my food, okay? I'd rather everything become dirty than me eating soap. Okay, but that's just me. Maybe your preference is to eat soap. If so, have fun. Okay, I'm not judging. Go eat all the soap that you want, man. But for me, I'm not about that life. Okay, I'm not about the soap life. Okay, I'd rather just eat germs. Okay. Stir it around a little bit more. Now again, we're not Jean-Pierre, whatever his name is. The guy who's like onion, the guy who says onion weird, the French cook. We're not Gordon Ramsay. Okay, we're not Bobby Flay. Bobby Flay? Yeah. I was going to say Bobby Flay, but it's Bobby Flay. We're not Bobby Flay. We're not Caesar Milan. We're none of these guys, okay? We're not Guy Fieri. We're not whoever the guy is from Pawn Shop. We're not whoever the guy is from Duck Dynasty. Okay, we're not these people. Who we are is someone who's just eating food to fuel up the body for the gym, okay? We're this kind of guy, okay? We have protein powder supplements with creatine in it that we just recently got as a gift. Okay, that's who we are. So we're not trying to make this taste amazing. We're not trying to make the most 10 out of 10 meal. Oh my god, okay? We're just making fuel for our body. Simply put, we are BP, the oil company, and we're making crude. We're using crude oil, and we're filtering it down into petroleum or gasoline to put into our car. Okay, that's pretty much it. This form, we can't just eat it like this. We gotta cook it a little bit, okay? And then we'll get something that we can actually eat. So I'm not going to wash this Tupperware because I've pretty much just put rice in it. So I'm just going to put the new rice that I'm making into this once that's finished. So we save on having to wash a dish. Would you look at that? Being lazy is truly a perk. Now this is where I would usually add soy sauce. Alert, alert, I know, soy. But here's the thing, okay, for all you, let me go on a tangent here. For all you gym heads, okay, who are worried about putting soy products in my food, soy is not the enemy, okay? It's not. The form of estrogen that's in soy-based products is not the same estrogen that's the hormone in your body, okay? Soy-based products are not the enemy. The enemy is plastics. These Tupperware containers. Okay, these plastics, they are the things that can mess with your exogenous hormones, I think it's called. The hormones that are in your body. Plastics and stuff like that can actually mess with it. So, lay off the plastics, okay? If you're a gym bro, get glass containers, not Tupperware. I can't afford glass containers. I can only afford cheap Tupperware containers. So that's why I'm eating from plastic, okay? The government wants poor people to become femboys. That's what they want, man. Now, I don't believe it's going to actually, like, do something that's, like, significantly noticeable. Like, oh my god, you eat from plastic? Like, no wonder you look like a, like, no wonder you look more feminine. You have more feminine features. I don't think it's that far, but it's probably does affect, like, you know, minor changes in your hormones can majorly affect your mood, stuff like that. So, it probably does affect that, so it's not good. Any extreme fluctuations in your baseline hormone level, it's probably not good, so don't do it. But yeah. I think I could keep this here, let it dry off for a little bit longer, I guess. So we got this, so we need to season it. Salt and pepper. I use sea salt, because I like sea salt. But apparently sea salt has a lot of plastics in it because the ocean is filled with plastics. So technically the best salt to get is pink Himalayan salt. Again, pink Himalayan salt that's like $5 extra at the grocery store. If you think I'm gonna spend $5 extra for like a slight benefit, I don't think so. I don't think it's generally worth it in that regard. But yeah, there's actually one thing that's quite blackpilling, and this is where we go on our podcast tangent bit. Okay, one thing that's actually quite blackpilling about the world today is how much the over-industrialization of everything has negatively impacted our well-being, like our health and well-being. What I mean by that is that, using like all of these plastics and everything has like a pretty much proven and, evident, or yeah, it's shown through evidence that it does have some sort of effect on our hormone profile, our exogenous hormones that are in our body. That kind of sucks, okay? And like everything being packaged in plastic at the grocery stores, everything being sprayed with all sorts of chemicals so that, it can last longer. And I know I hate using the buzzword like, oh, this has chemicals in it. Chemicals are bad, because water is a chemical, H2O, dihydrogen monoxide. That's a scary chemical. I don't like using those buzzwords, but they're I should say this. I should correct myself. Like all these places are using harmful chemicals in our foods and everything like that, so that they can preserve it, make them last longer, etc., etc. It's just kind of sad that our entire world is kind of designed in a way where, like, it's extremely difficult to live a healthy life if you have like less money. Like, it's kind of weird that incentives are set up in our world such that to live a healthy life, you need to have a lot of money. Like, I don't think we should probably, I think it's fine to, lock pleasures and entertainment behind some paywalls, like, oh, hey, you're poor, so you can't afford a PS5. I don't think we need to give headset just turned off. But I don't think we need to give PS5s to a bunch of poor people. Like, I don't think that's what we need. I don't think we should, go to, poor neighborhoods and be like, you get a PS5, you get a PS5. We can leave that to, Mr. Beast videos. Leave the charity of entertainment stuff to Mr. Beast videos. But I think if you, wanted to become an optimal, human, if you want to run your body as optimally as possible, locking that behind a paywall just seems really, gross, disgusting, because, the well-being of your body is, in a hierarchy of, what is important in someone's life. Some people might be like, your career is the most important, or your family is the most important, and, health is down here. That's not true. Health is actually the single most important thing in your entire life, okay? And that's simply because if you're an unhealthy person, you are not going to be able to live your life. You're not going to be able to do things. If you're, I guess to take an extreme example, if you're eating negative foods that end up having some carcinogenic effect on your body, you are just objectively worse off in your life. You can do less things. We would never hand someone cigarettes for their entire life and then be like, hey, go try to be a marathon runner, and then get upset at them when they can't be a marathon runner because they're smoking a pack of cigarettes every day. That's kind of, it's not a one-to-one analogy, but, it's kind of what we're doing to everyone in the world today, where basically we're just, for poor people, we're okay, you only have access to these kinds of foods that are cheap, which are extremely highly processed foods that are very high in sugars and sodium and everything like that, and they have very low satiety. And if you want any, if you want to round off, if you want to get the amount of micro and macronutrients that you want for the day, it's going to be extremely expensive, so you can't really buy like fresh vegetables or anything. Go buy like canned fruits and canned veggies and stuff like that. Um, like it's, that kind of sucks, you know. Like as someone myself right now, I don't imagine I'm gonna be like living poorly for the rest of my life. I'm just poor right now because I'm in university. I don't really have a main source of income or like a main, yeah, I don't really have a steady source of income from somebody that I can rely on right now. I'm just kind of free soloing the university life. And, you know, as someone like that, like, I'm kind of going through the extreme motions now where it's like, okay, I have $10 in my bank account this week. What the hell can I buy to eat? How can I make it to the next day? And you know, I see eggs are on sale for $2, so I'm like, oh shit, I gotta buy like probably 2 cartons of eggs, you know, whatever, fulfill all my other things with protein powder, stuff like that, whatever. Like I can still kind of make it by, but it's very inconvenient to like try to choose like very healthy options. A lot of times I have to go off to things that are like, you know, just not good for you. Like I had to buy like a pack of hot dogs today because hot dogs are $1.99, but ground beef is like, you know, $16. Like I can just get the equivalent like weight or food in hot dogs for a lot cheaper than buying ground beef. But like yeah, the whole point of that is that like I think eventually probably later down the road of my life I'll be able to have the luxury to choose more healthy options that are more optimal for my health. But I think like the fact that like most of the population that are like not middle class, that are kind of like lower income people, it really is horrible that kind of for them to choose health is kind of like something that's like an extreme option. It's like, oh shit, like sorry kiddo, like sorry my kid that I'm raising, I can't really give you the healthy food option, so here's the cheapest milk that I could buy from the store that is filled with, you know, random hormones and probably like a lot of different stuff that's not healthy for you. Sorry I couldn't get you the organic milk or raw milk option. Like I couldn't afford it. That kind of sucks. I think it's probably better if the world is like, it's better if a parent has to go to their kid and be like, "Hey kid, I couldn't really buy the newest iPhone, so here's like, you know, a Samsung burner phone, but it still works. You can still download, you know, your Twitter, your Facebooks, your Instagrams, all the things you want." I think it's better to live in a world like that rather than like, "Hey kiddo, I couldn't like afford to buy you fresh veggies and foods, so here's some dino nuggets that I bought from the discount section of the store that are probably already expired, and you know, here's a 20-piece nuggets from McDonald's because they have a reward going on where I can buy it for $6. Yeah, like, and here's highly processed white bread. Live off that. You know, like that's kind of a sad world that we live in, but it's the world we live in nonetheless, I guess. Yeah, that's my tangent. Tangent over. Tangent cut. Smash cut tangent. Done. Yeah. Yeah, it sucks having to. Right now, I'm really living the poor life. And I know a lot of people say that, and they're like, "Oh, I'm living the poor life, whatever." But like many life circumstances have led me to the point where in the past 3 years, not my income personally, because I don't have an income, but my like the money availability in my life has drastically decreased a lot. A lot. Okay, a lot. So yeah, I'm kind of mooching off people, saying, "Hey, can I have $5 here? Hey, do you have a kid you need a tutor? I can tutor him. Just give me money." You know, I'm kind of in that section of my life right now. So yeah, what I'm saying is that I recognize your struggle. Okay, poor people out there who are watching YouTube live streams, I am. I hear you. I feel you. So give me money. Give me your money. Okay. Okay. I think the rice is done. I think so. I'm gonna turn it for a little bit longer. Actually, I probably should have covered it while I turn it on. I'm gonna turn it on for a little bit longer while I transfer the rice, green beans, and onions into this. Rice, green bean, and onions. Like again, like also I'm technically, well, I was in a bulking phase for like the past 3 months. I think now I'm in my main gaining phase because I've hit 200 pounds. So I should probably just work with that for a bit so I don't have to eat as much food. But like bulking when you don't have much money and you're trying to be healthy, holy hell, that's a task, man. That is quite the task. Okay. So I've been like trying to choose the healthiest options that I can, honestly, and it's hard, dude. It's really hard. But I think like for any other poor cells out there, okay, if you're a poor cell, no money cell, gym cell, then the cheat code is rice, bags of either onions or potatoes, or both of them if you can, and frozen mixed veggies. That's the cheat code. If you have those, then supplement it with either a protein shake or sardines are probably the cheapest and healthiest form of fish that you can eat. That would give you optimal protein and omega-3s as well. But sardines now are also getting expensive. So I'd say sardines, tuna are like the cheaper options for a good source of protein. And some other. Is omega-3, would those be micronutrients or macros? I think those would be micronutrients. Good source of protein and other micronutrients. And if you can afford it, or if it's at discount for like buy one get one free at Safeway or something, ground beef or chicken, those are really good protein sources. I personally like ground beef a lot because I find it tastes better and it's easier to cook. Like you need to put like I don't need to put much things in ground beef to make it taste good, except for like salt. That's pretty much it. But for chicken, I find I need to put like usually the way I cook my chicken is I'll boil my chicken. White person moment. But I'll boil my chicken and I'll shred it. So basically, I make shredded chicken in some mayonnaise with some salt, pepper, red chili flakes, that kind of stuff. But yeah. So that's kind of the cheat code. If you really need cheap sources of food, okay, buy a big, and buy in bulk. You have to buy in bulk as well because that's the cheapest way to get these foods. But buy in bulk. What is it? Rice, some frozen mixed veggies, some onions, some potatoes, and some sort of meat, whether that be sardines in bulk, whether that be tuna in bulk. If you get tuna, though, get the chunk light tuna. Don't get albacore tuna. Albacore tuna is usually, I think it's made from like a much bigger and older tuna. And basically, the bigger the fish and the older it is, the higher mercury levels it'll contain. That's kind of like a loose rule of thumb. I think the main rule of thumb is just how long the fish lives. And I think for albacore tuna, they live for pretty long. So don't get albacore, get chunk light. I forget, I'm not entirely sure where chunk light comes from, but I just know it's the better form, less mercury in it. So for protein sources, either sardines are a really good choice, chunk light tuna is a really good choice, or chicken, you can never go wrong with chicken, or ground beef. But ground beef, try to get more lean, like 90% lean, 10% fat. If you have to, 80% lean, 20% fat, especially if you're bulking, that's fine. But yeah. Fat is good for you, by the way. Don't think that fat is an evil thing. Fat doesn't make you fat, okay? What makes you fat is excess calories. That's what makes you fat. And alcohol in some cases. I believe alcohol, um, if you drink alcohol in excess, like, I think when you drink alcohol, I think it just immediately bypasses, like, it just goes straight into, like, your fat storage parts of your body. I don't think you can drink alcohol and then go run on a treadmill for like 30 minutes and burn the alcohol that you just drank. I think the calories from alcohol are just in your system. Like, you can't burn them off. So don't drink alcohol. Not great for you. For health and gym purposes, of course. Of course, there are probably going to be exceptions to that rule, but in general, don't drink alcohol. It's not generally good for you. Okay, that's fine. Okay, meal prepped. I'm going to leave it here on top of the toaster oven to cool down. Let's put this back like that. Okay. Cover to this. Let's put that down here. Just checking my phone. Can a dude not check his phone? Okay? Back off, bro. Back off, dude. Just let me check my phone. Okay, can a dude not check his phone in the 21st century nowadays, where we've entirely organized our life to be orbiting around this device that we have to keep on our persons at all times? Fuck, man. The way that the modern world is going is, I don't think it's great, but maybe it is. I hope it is. Okay, I hope I'm wrong. I hope the modern world is going to be great. I hope that the future led by, OpenAI, it's probably not going to be OpenAI, honestly. I think ChatGPT is probably run its course. I think the future is probably going to be like some AI that either Apple or Google would make. But whatever future that we're brought into by tech bros in San Francisco, I hope it's a good one. And it's not going to be a good one on purpose, okay? It's not going to be like, yeah, we totally planned this out so we can have a good world. It's going to be entirely by chance, okay? Because none of these people working on these technologies even care about, the philosophy of things beyond like a prop logic course or something like that, or like some stoicism YouTube video they watched. Yeah. It's quite heavy, dude. My hand is hurting. I went rock climbing today. My hand is a little bit sore. Hand and forearms and fingers. Climbing really takes a lot out of you. Okay. Got this. Yeah, see, this is probably bad for my health. This is probably leaching the plastics in the Tupperware into the rice. You can see how hot it is. But you know what? But you know what? And I'll leave it at that. More rice coming right up. Did someone order? Hi, so I've got an order of rice for the table. Yeah, so I've got an order of rice for someone? Oh yeah, that's me. And then another order of rice. Oh yeah, that's her right there. And another order of rice. Yeah, that's him right in the corner. And another thing of rice. Oh yeah, that's me. Yeah, okay, thank you. Enjoy your meal. Yeah, thanks. I will. I'm going insane, dude. Okay. Here's the part that's kind of hard. A bunch of rice. It's kind of stuck to the edges and to the bottom of the pot. I try to scrape it off, but I don't think the ones at the bottom will come off. Probably the sides will come off easier. Yeah, I think I added probably too much water again. So I think the moral of the story is that for this rice, I can add a lot less water than I think is necessary. Scrape off all the excess rice. Okay, we need every bit of it. Don't waste a drop. And boom. Put it right in here. Boom. Call of Duty Black Ops 1 sound effect when you grab the nuke. God. God damn, dude. That's another tangent I can go on. Just older video games, man. Oh, when people were trying to make new stuff that was cool, and they weren't trying to make, like, you know, the easiest thing that can make them $1.250. Alright, let's put this in here. Fill up the pot with water. Let it soak a little bit. Okay, seems sufficiently soaked. Let's leave it there for a while. So I'm probably not going to do dishes. Probably going to wash that pot at the same time, so it needs to soak for some time. So yeah, that's that. What else? Okay, I think I'm. What the hell? Hello? Okay, I think I'm done with everything that I need to do standing up. So I'm gonna switch to the proper mic soon. Yeah. I'm gonna switch to the proper mic soon. And we are going to begin reading. Probably gonna do my homework tomorrow. So today is a reading day. Tomorrow is a homework day. Okay? Yeah. Yeah. I need to adjust my monitor. Okay, so the mic turned off anyway, or the headset turned off. I think it auto turns off if you don't do anything with it for an hour. Or not an hour, probably 30 minutes? No, probably 15 minutes actually. Probably some power saving thing. Like if it doesn't hear any audio, even if you're sending audio, which I guess would probably make sense. But they can probably add a noise gate to it. You can probably add a noise gate to the microphone where if it's above some certain threshold, then it would keep it on. But I guess you can also just live in a noisy environment, I guess. So there's probably no easy solution to that. So probably just shutting it off when nothing's going in is probably the easiest thing to do to save energy. But yeah. Okay, so we're going to switch to the main cam. I'm going to move this to the side here so as to not break the fourth wall. And what I'm going to do is open up text edit, new document, be right back. Because I will be right back. And let's put BRB for any of these new millennials here who don't really know what be right back means. Can we center a line? I don't think we can. Text. Yeah, because this is rich text. Or not rich text, just plain text. Yeah, I think it's plain text. This is plain text. But yeah, be right back soon.
Guess who's back? Me. I'm back. I'm back, baby. Better than ever. Okay? Back better than ever. So, what we're going to do now is very simple. Okay, we have a very simple task at hand. What are we going to do? We're going to read through this, through 2.2 and 2.3, and then get to 3, read 3.1, 3.2. So, how big is 3? It's not too bad, actually. So, we're going to read 2 and 3. So, we read Einstein's calculation. So, what was something that we learned last time reading about Einstein's calculation? Okay, let's think about it. But before that, let me pull up our trusty companion ChatGPT on the side to help us read through some of this stuff. By the way, if you're still a ChatGPT hater, I hate ChatGPT as much as the next person, okay? I don't think we should be using language learning models to rely on everything in our lives, okay? It's pretty stupid when it comes to making new stuff, but what ChatGPT is really good at is taking existing information and summarizing it or rewording it. And that sounds like something that's perfect for reading a textbook. You give it already existing information that you know is factually true. A textbook has to be factually true, right? If it's not, then Jesus Christ, you probably shouldn't be reading from the textbook if it's not factually true. But like, you can take a screenshot of this, right? Put it into ChatGPT, just say, hey, can you explain this simply? And it will do it, and it will do it really well because it has facts to go off of. It's basically just, it's like a more trained person just looking at this and then saying, okay, this is what it's talking about, basically. So it's really useful for stuff like that, personally. Not just personally, but like objectively. Let's double check and see. Yeah, for some reason, my thumbnail is not changed. So let's change this thumbnail. I don't know why it's not uploaded. Save. Now it should be fine. Should be updated. Thumbnail. Should be updated. Thumbnail. I think it is. We can probably increase the gain on this as well when we hit the yellow. So increasing the gain, we're increasing the gain. Hello, we're increasing the gain. See how that sounds? When we hit the yellow. So increasing the gain, we're increasing the gain. Hello, we're increasing the gain. See how that sounds? Okay, what if I turn up the peak as well? If I turn up the peak, how does that sound? I don't really know how that affects things, but if I turn up the peak, how does that sound? I don't really know how that affects things, but okay, so we'll keep the peak there, keep the gain here. I think this is fine, right? I don't know if it's just, could just be my setup, but yeah, whatever. Yeah, it's in the yellow. It's in the yellow. It sounds good. It's in the yellow. It's in the yellow, so it should sound good, okay? But yeah, so we've already looked through the Einstein calculations. So Einstein's calculation is basically taking this thing called the partition function, which takes a sum of all of the possible states of a system. Blah, 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 yada, yada. They do a specific factor, which they do in e to the x minus 1. There's another calculation, which is the Debye calculation, where instead they have plus 1 instead of minus 1. Jesus Christ, dude. What the hell? Let me fill up on more water, actually. just leave it open, I guess. Remind me to wash this bottle as well today. It's been a minute since I last washed it. I should probably wash it. To clean up bacteria and stuff like that. Dude, my throat, man. Still have phlegm, residual phlegm. It's never going away, is it? I don't think so. Okay, so now we're going to read about Debye's calculations. So, Einstein's theory of specific heat. Let's turn down the gain a little bit. Well, we don't want to talk too loud, so actually let's turn up the gain. Einstein's theory of specific heat was extremely successful, but still there were clear deviations from the predicted equation. Even in the plot in his first paper, one can see that it... So figure 2.2? Yes. One can see that at low temperature, the experimental data lie above the theoretical curve. Kind of, I guess, at low temperature? I guess. Kind of lies above, but I think this is pretty accurate. If I came up with this, I'd be like, this is really accurate. This result turns out to be rather important. In fact, it was known that at low temperatures, most materials have a heat capacity that is proportional to T cubed. See, for example, 2.3. Okay, that looks better. Metals also have a... Jesus, man, I'm sorry. Just finished eating, so I think a lot of talking is probably gonna... I didn't just finish eating. When did I eat? When did I eat? Probably an hour ago, I guess. Probably takes long for my body to digest. I don't know. Whatever. Magnetic materials may have other additional terms as well. Non-magnetic insulators only have the T cube behavior. At any rate, Einstein's formula at low temperature is exponentially small in T, not agreeing at all with the actual experiments. So his formula at lower temperature is exponentially small in T. What does it mean exponentially small in T? His formula is small in T, which doesn't agree with actual experiments, so I guess it's larger in T. Oh, I guess, yeah, exponentially small in T. The wording of this, dude. In 1912, Peter Debye discovered how to better treat the quantum mechanics of oscillations of atoms and managed to explain the T-cubed dependence on the specific heat. Debye realized that oscillation of atoms is the same thing as sound, and sound is a wave, so it should be quantized the same way as Planck had quantized light waves in 1900. Wow, makes sense. I kind of have this crackpot theory. I don't know if this makes any sense, but my crackpot theory is that fundamentally, probably, the world just exists as vibrations. I think that's probably the most fundamental thing, is vibrations. I don't know. I haven't studied quantum field theory. I don't know about the field of, the field of fundamental particles, whatever. I don't know about that field stuff, like certain vibrations on the field, Higgs bosons. I don't know, but that's just my crackpot theory, not knowing any physics and not knowing any of the physics behind it. Debye realized that oscillation... Yeah, okay, I just read that. Besides the fact that the speed of light is much faster than that of sound, there's only one minor difference between light and sound. For light, there are two polarizations for each wave vector k, whereas for sound, there are three modes for each k. Okay, a longitudinal mode where the atomic motion is the same direction as k, and two transverse modes where the motion is perpendicular to k. Light only has transverse modes. Huh. Let me ask ChatGPT to explain this. Explain more about why light has... Oh, Jesus. Don't grate along that. Explain more about why light has two polarizations for each wave vector k, but sound has three. Do 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 do. Okay, we might as well pull it up here, I guess. So the passage you provided discusses the difference in the number of polarizations between light and sound waves. To understand this, it is important to consider the nature of these waves. So sound is a mechanical wave, meaning it requires a medium to travel through. Sound waves in a solid can be longitudinal or transverse. In a longitudinal wave, the displacement of the medium is parallel to the direction of the wave of propagation. In transverse waves, the displacement is perpendicular to the direction of wave propagation. In solids, sound can propagate in both longitudinal and transverse modes. Can you explain this more simply / intuitively? I'm still struggling to understand what displacement and oops. So longitudinal waves, imagine a slinky. If you hold one end and push and pull it back and forth, you'll create areas where the coils of the slinky bunch up and then spread out. These bunched up areas are called compressions, and the spread out areas are called rarefactions. Is that true? What is a rarefaction? Huh. Yeah. Seems like it. So the wave travels along the slinky in the same direction that you are pushing and pulling. This is similar to how sound waves travel through air or any other material. The particles in the material move back and forth in the same direction the wave is. Oh, okay. That makes sense. Okay. So transverse waves. Now think about being at a stadium where people do the waves, standing up and sitting down in sequence. Here the motion of the people is up and down, but the waves travel around the stadium horizontally. Okay. Yeah. So if you were to use a rope instead of people, you would shake one end of the rope up and down or side to side, and the waves would move along the length of the rope. The important thing to notice is that the movement of the rope particles is perpendicular to the direction the wave is traveling. Oh, okay. So in the case of light waves, because there's no medium, we're talking about the oscillation of the electric and magnetic fields rather than the motion of particles in a medium. Okay. For each direction a light wave is traveling, there can be two perpendicular directions in which the electric and magnetic fields can oscillate, and these are the two polarizations mentioned. For sound in a solid, we have the longitudinal mode and two kinds of transverse modes, like the rope shaken up and down, making 3 in total. In gases or liquids, there's generally only the longitudinal mode for sound because those mediums can't support the shear stress that's needed for transverse waves. Okay, that's pretty good, actually. Nice. See, this is what ChatGPT is all about, okay? I don't... Explore GPT is... What is this? Oh, wow. Huh. Anyway, but... if you're using ChatGPT for, like... inventing something, like give me a cool idea for an art project, hell no, don't do that type of stuff. Just use ChatGPT for what it was designed to be, which is basically just a very sophisticated thing that can comb through a lot of data and interpret the data for you. The longitudinal... I shouldn't have done that directly into the mic. I'm so sorry. Jesus, I'm so sorry, by the way, that I have to keep clearing my throat. This probably sucks to listen to, but... So... longitudinal velocity is usually somewhat greater than the transverse velocity. That kind of intuitively makes sense. That is going to be faster than the movement up and down. So we now repeat essentially what was Planck's calculation for light. This calculation should also look familiar from your statistical physics course. I didn't take stat physics, so boom. First, however, we need some preliminary information about waves. Periodic boundary conditions. Many times in this course, we will consider waves with periodic or Born-von-Karman boundary conditions. It is easiest to describe the first in one dimension. Here, instead of having a one-dimensional... My nose, dude. I think stuff from outside is like messing with my nose. And it's probably stuff outside that I'm low-key allergic to, maybe? I don't know. Who knows? Here, instead of having a one-dimensional sample of length L with actual ends, we imagine that the two ends are connected together, making the sample into the circle. The periodic boundary condition means that any wave in this sample e to the ikr is required to have the same value for position r as it has for r plus L. We've gone all the way around the circle, okay? This then restricts the possible values of k to be equal to k equals 2 pi n over L. That makes sense because the circle is 2 pi, so any multiple of 2 pi is going to be what k can be. Whoa, we just went dark mode. That means the sun just set. For n an integer, if we ever required to sum over all possible values of k for large enough L, we can replace the sum with an integral obtaining. So we replace the sum with an integral. Sum of k for L over 2 pi. Integral from infinity to infinity of dk. A way to understand this mapping is to note that the spacing between allowed points in k space is 2 pi over L, so the integral of dk can be replaced by the sum over... Don't really get that? ChatGPT time. Explain how we get the formula near the bottom. The formula near the bottom of the image you provided is a mathematical expression that comes from quantum mechanics and solid-state physics describing how to deal with sums over wave vectors k. We're considering a system that's finite in size but without any edges. It is as if the system wraps around in a loop. For a one-dimensional system, it's like bending a line into a circle. Now, if you have a wave in such a system, the wave must be the same after it travels a distance L, because at that point, it's back to where it started. Mathematically, this means that e to the ik r plus L equals e to the ikr, yes, which implies e to the ikl equals 1. The condition e to the ikl equals 1 is satisfied when kl is an integer multiple of 2 pi, leading to the quantization condition for k. K is equal to 2 pi n over L. For a large enough system where L is very large, the allowed values of k become very densely packed. In the limit of an infinitely large system, the sum over these discrete values of k can be replaced by an integral. That's where the formula at the bottom comes in. The replacement of the sum by an integral can be understood as follows. Oh, this arrow is meaning that it's being replaced. Okay, I didn't quite understand that. The sum over k is actually a sum over n, because each k corresponds to an n via k is equal to 2 pi n over L, where L is very large. The difference between successive values of k, which is delta k equals 2 pi L, becomes very small, and the sum can be approximated by an integral. The sum over k is actually a sum over n, because each k corresponds to an n. So when L is very large, the difference between successive values of k becomes very small. Yeah, when L is very large, k becomes very small, okay? And the sum can be approximated by an integral L over 2 pi, integral of negative. Okay, density of states, don't quite understand. This is kind of a stupid analogy. Because, like, it's not like when you go into a hotel, the higher the floor means the more rooms there are available. It's just not really how it works, but sure. I kind of get what you're talking about. This is a good response, though. So it's a way to tally up the available quantum states at each energy level in a system. It's a fundamental concept that helps physicists understand and predict the behavior of matter at the microscopic level. Okay. In 3 dimensions, the story is extremely similar. So for a sample of size L to 3, we identify opposite ends of the sample, wrapping the sample up into a hypertorus. Okay. So that if you go a distance L in the X, Y, or Z direction, you get back to where you started. As a result, our K values can only take the values this. Yeah, N1, N2, N3. Ah, I remember this. Okay. So each K point now occupies a volume of 2 pi over L cubed. Debye's calculation following Planck. Is it Debye? Is there a speech option? Debye? Yeah, it's Debye. Okay, Debye. Debye decided that the oscillation modes of a solid were waves with frequencies omega k equals vk, with v the sound velocity, and for each k there should be 3 possible oscillation modes. Okay, 1 for each direction. Okay, get it? One for each direction of motion. Thus, he wrote an expression entirely analogous to Einstein's expression. Yep. Each excitation mode is a boson frequency. Is a boson of frequency omega k and is occupied on average nb times. By spherical symmetry, you may convert the 3-dimensional integral to a 1-dimensional integral. So 3D to 1D. Okay. Yeah, because it's spherically symmetric. Which would make sense. Call that 4 pi k squared is the area of the surface of a sphere. Okay, yep. Yes. This is true. I like to do the pedantic way. Because it makes more sense, dude. If you do some shortcut like this, you don't really... Actually, no, do you? No. Okay, actually, I think both ways are kind of valid, but if you had some different problem, like let's say instead of like spherical symmetric, let's say it's like symmetric along some weird different shape, then you should... Doing this integral would always give you the answer for what that's going to be, rather than like going off this like cheap little trick of like 4 pi k squared is the area of the surface of a sphere. Mm-hmm. Mm-hmm. This is the Debye frequency, okay. So the meaning of the density of states here is that the total number of oscillation modes with frequencies between omega and omega plus d omega is given by that. Thus, the interpretation of equation 2.4 is simply that we should count how many modes there are per frequency. Then multiply by the expected energy per mode, and finally we integrate over all frequencies. Count how many modes there are per frequency. That is how many modes there are per frequency. Then multiply by the expected energy per mode, and finally integrating over all those frequencies. Yep. 2 over 3 by 3 over 2 over c with 3 over c. 3. No, it's probably this. Yeah. Yeah, it's 3 over v cubed. We pull out a 3 from here. The other change from Planck's classic result is the plus 1/2 that we obtain as the 0-point energy of each oscillator. At any rate, the 0-point energy gives us a contribution which is temperature independent. Okay, let me just take a screenshot of all of this actually, and then just ask ChatGPT to explain it simply. Oops. I don't know how high res that is, but whatever. Thank you for the simplified breakdown, please. I need it. Or I'm gonna break down simply. It's not that funny. Do. Dude, it's hard to do things when you're sore. Like right now I'm just sore. Like my whole body is just sore. It's kind of funny. Okay. Enough with the distractions already, please. So these are breakdowns. So quantization of vibrational modes. In a solid, atoms vibrate around their equilibrium positions. These vibrations can be thought of as waves. And according to quantum mechanics, these waves can only have certain allowed energy levels. Debye theorized a model where these energy levels depend on the frequency of the phonons and are quantized. The energy of each phonon mode is given by h bar omega k? Not omega. Is that omega? Small omega, I think. Yeah. Where h bar is reduced Planck's constant and omega k is the phonon frequency as a function of the wave vector k. The average number of phonons in each mode is given by the Bose-Einstein distribution. To find the total energy, use sum or just stab myself with a string. Guitar string, not a nylon string. Not guitar strings are also made of nylon, not a rope string, not a string made out of rope. To find the total energy, you sum, integrate. In the continuous case, the energy of each mode multiplied by the average, blah, blah, blah. The number of available states of the given energy is crucial. Okay, I don't really understand this, but it's okay. As long as I've seen it, hopefully he'll cover it in a lecture, the professor, if he's a good professor. But maybe he isn't. But maybe he isn't. Who knows? Notice the similarity to Planck's derivation of the T to the 4 energy of photons. As a result, the heat capacity is that this correctly obtains the desired T cubed specific heat. The prefactor of T cubed can be calculated in terms of known quantities such as sound velocity. Note that the Debye frequency in this equation is sometimes replaced by a temperature, known as the Debye temperature. So that this equation reads that phonons are quantized sound waves. Okay, let's sit up. Maybe that's why I'm tired. You gotta sit up tall. Okay, how are you gonna learn if you're not sitting up tall? You gotta put on a proud posture so you can see that you're proud of the work that you're studying. Okay. In a solid, atoms can vibrate, and these vibrations can be modeled as phonons, which are quantized sound waves. The Debye model assumes a maximum frequency for these phonons, called the Debye frequency, beyond which no vibrational modes exist. The Debye temperature is related to the specific heat capacity of a solid at low temperatures. According to the Debye model, the specific heat capacity of a solid at low temperatures varies with the cube of the temperature, T to the cube, and it approaches the Dulong-Petit law at high temperatures. The Debye temperature arises from the quantum mechanical treatment of lattice vibrations and statistical mechanics, providing a way to calculate the low temperature specific heat that agrees well with experimental data. Physically, the Debye temperature can be thought of as a temperature at which all phonon models in the solid are excited. Below the Debye temperature, the specific heat of the solid is less than the classical value predicted by the equipartition theorem, and it decreases with the decrease in temperature. So the Debye temperature is a temperature at which all phonon modes in the solid are excited. Below the Debye temperature, the specific heat of the solid is less than the classical value predicted by the equipartition theorem, and it decreases with the decrease in temperature. So the Debye temperature is a fundamental property of materials and can be used to estimate other physical properties such as thermal conductivity and elastic property is. So the Debye temperature can be calculated from the speed of sound in the material, the density of the material, and the number density of atoms or molecules in solid. In summary, the Debye temperature provides a scale for understanding the thermal properties of a solid, especially the behavior of its specific heat at different temperatures. It is a useful concept for describing how a material's heat capacity changes from the classical regime at higher temperatures to the quantum regime at lower temperatures. When you heat up most materials, they absorb heat and their temperature rises. The measure of how much heat they can absorb is called heat capacity. At high temperatures, well above the Debye temperature, the materials behave classically, meaning they absorb heat energy in a predictable, straightforward way that doesn't depend on quantum effects. This is similar to how you might expect. The more heat you add, the warmer the material gets. However, as you cool the material down, especially down to temperatures close to or below the Debye temperature, things to get a bit more quirky. Shut the hell. Oh my god. They're programming ChatGPT to do quippy one-liners. I need to disable it from doing that. God damn. At these low temperatures, the laws of classical physics aren't enough to explain what's happening. Instead, quantum mechanics takes over. Here's why. In quantum mechanics, energy comes in discrete chunks called quanta. At low temperatures, the chunks of vibrational energy, or phonons, in the material can't be divided any smaller. There's a minimum energy required to excite the atoms in the material to a higher energy state. The minimum energy required to excite the atoms in the material to a higher energy state, yes. For it to jump from this level to this level, there's a minimum amount of energy required to make that jump. Because it's discrete, it's not continuous. If it was continuous, you can insert 1 electron volt and it'll go like there, and then you just keep doing that until it hits there. But instead you need to insert 10 electron volts and then it makes that jump. Because of this energy gap, fewer vibrational modes are active at low temperatures. Many of the atoms are stuck in their lowest energy state and can't absorb heat to move to a higher state. Since fewer atoms can jump up to higher energy states, the material can't absorb as much heat. This means its heat capacity decreases. So at low temperatures, the material's heat capacity changes because atoms can only absorb heat in specific amounts. If the heat isn't enough to reach the next energy level, it won't be absorbed, which is why the heat capacity goes down as the temperature goes down. Okay. This is what's meant by the quantum regime. Okay. Inhabiting. Hmm. In quantum mechanics, if a particle requires a specific amount of energy to transition to a higher energy state, it indeed cannot absorb less than the amount. If a particle is supplied with less energy than the required quantum, it won't be able to use that energy to jump to a higher energy state. However, the concept of emitting the energy back into the environment isn't quite as straightforward. In a quantum mechanical system, if the energy supplied is not sufficient to cause a transition to a higher energy state, the energy may not be absorbed at all. It isn't that the particle absorbs and then re-emits it. Rather, the interaction that would have supplied the energy doesn't effectively happen. This is particularly true for processes like photon absorption by an atom or molecule. For instance, if you shine a light on an atom and the photons don't have enough energy to excite the electrons to a higher energy level, those photons will not be absorbed. They may be reflected or transmitted instead. The atom remains in its original energy state and the photon continues on its path, unchanged by the encounter. This principle underlies many phenomena, including why certain materials are transparent to certain frequencies of light. Okay. Because it'll absorb it. When it absorbs it, does it appear darker or lighter? If you reflect it, it'll be like a mirror. But if it absorbs it, it'll be like a black screen? I have no idea. In a more macroscopic view, if you add thermal energy to a system, the energy can still be distributed amongst the particles in various ways, such as increasing the kinetic energy of the atoms, making them move faster but not changing their quantum state, or it could be transferred to the surrounding environment in other forms, such as through radiation or conduction. The key is that if the energy isn't the right size or amount to cause a quantum jump, it won't cause that specific transition. Okay. Transition. Have you given this album a listen? Did you love it? Did you hate it? What would you rate it? You're the best. You're the best. What should I review next? Hit the like if you like. Please subscribe and please don't cry. Up above my head is another album review I did. Blah 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 blah. Anthony Fantano. Whatever this album is, forever. Only real G's know that outro. Jesus, I need to be drinking a lot more water because creatine. Let me fill up some more water real quick. I don't even know why I'm wearing these headphones, to be honest. I'm not listening to anything. So I really don't need to be wearing them. Don't know why I am. Dude, my body is so physically sore. Like my back in particular, my upper back is sore. That it makes me feel like not doing anything. Because I'm like, dude, I'm sore. Like, why should I do anything? I'm sore, man. Oh, but I should still do stuff. Because I haven't really done much. We're learning a lot. We're updating our models, basically. The most important thing of reading, listen, if you read a textbook just to understand what the textbook's saying, you're not really reading a textbook, okay? You should read a textbook with the goal of understanding not only what they're trying to get across, well, actually, no. Because for reading a textbook, you want to understand exactly what they're trying to get across. But to understand that, you're going to need more knowledge than what the textbook gives. Because 99% of textbooks are written like garbage, where they just assume you have a bunch of knowledge. And so really this textbook is meant to be something that teaches the basics of solid state physics. But in reality, what this is the basics of solid state physics for people that know about quantum mechanics and people that know about statistical mechanics as well. Which makes your subset of people that you want to try to reach out to incredibly smaller. Which in my opinion is just garbage. Like, why would you, when you write a textbook, you should just mention these things, man. Just like, I shouldn't be having to look all these things up. And maybe you can put the blame on me, but I guarantee you a lot of people who are taking my class right now on solid state physics will also require looking it up. But that's none of my business. I can't believe I did that. Okay. Debye's interpolation. Okay, after this, we're on to chapter 3. And chapter 3 is not, it's not as long. We can finish chapter 3 easy. Easy, boy. So what was this even talking about? I don't even know what Debye's calculate. Okay, the main takeaway is that Debye considered not just light waves like Einstein did, but he considered that atoms can vibrate like as sound waves, which have 3 different vibrational modes, which is transverse, longitudinal, and what are the 3 modes? Transverse, longitudinal, and pretty sure I should have it up here. Longitudinal or transverse. Two polarizations. There are 3 polarizations. Longitudinal and 2 transverse modes where the motion is perpendicular to K. Yeah, okay. Longitudinal and 2 transverse modes. Yeah, okay. I don't quite understand why there are 2 transverse modes, though. I guess back and forth? Perpendicular to the direction of wave propagation. Oh, up and down. Transverse, right? Well, up and down, left to right. So it's traveling in this way. It can move that way. It can move this way in the direction of motion. But the longitudinal is in the direction. It can be squashed or open. But because light travels at the speed of light no matter what, that they're just transverse. Yes. No, they can be longitudinal as well. Wait, what is longitudinal again? Yeah, it's that, right? Okay, I guess that makes sense. Light waves consist of electric and magnetic fields oscillating perpendicularly to each other in the direction of the wave propagation. This is a defining characteristic of electromagnetic waves described by Maxwell's equations. Longitudinal waves involve oscillations in the direction of wave travel, typically requiring a medium through which to propagate, as the wave function involves compressing and rarefying the medium. Electromagnetic waves, including light, do not require a medium. They can propagate in a vacuum where there is no materials. What? This guy is actually just insane. Okay, sure. I don't really get that, but okay. Okay, I'll believe you. Okay, Debye's interpolation. Let's read this. Let's read the interpolation part. Read through chapter 3. Can we really make it through chapter 3? I'm really tired, dude. Holy shit. Oh my god. Maybe we can. God damn. Let's just read it. Let's not think, let's just read it. Unfortunately, now Debye has a problem. In this expression just derived, the heat capacity is proportional to T cubed up to arbitrarily high temperature. However, we know that the heat capacity should level off to 3 kBn at a high T. Debye understood that this problem with his approximation is that it allowed an infinite number of sound wave modes up to arbitrarily large K. This would imply more sound wave modes than there are atoms in the entire system. Debye guessed correctly that really there should be only as many modes as there are degrees of freedom in the system. This is an important general principle. To fix this problem, Debye decided to not consider sound waves above some maximum frequency omega cutoff, with this frequency chosen such that there are exactly 3 n sound wave modes in the system. 3 dimensions of motion times n particles. 3n is going to be equal to the integral of 0 to the frequency, to the cutoff frequency of g. Correspondingly, rewrite equation 2.4 for the energy with that. Yeah, note that at very low temperature, this cutoff does not matter at all, since for large beta, the Bose factor NB will very rapidly go to 0. At frequencies well below. For high temperature, NB is equal to that. Wow, Debye's is more accurate. Einstein is very slightly not accurate goes off here, but Dubai was just ever so slightly more accurate. um. Okay. Should be emphasized that the Debye theory makes predictions without any free parameters, as compared to the Einstein theory, which had the unknown Einstein frequency as a free-fitting parameter. Some shortcomings. The introduction of the cutoff seems very ad hoc. It seems like a successful cheat rather than real physics. Dude, that's what physics is. We've assumed sound waves follow the law omega equals vk, even for very large values of k. Whereas the entire idea of sound is a long wavelength idea, which doesn't seem to make sense for high enough frequency and short enough wavelength. At any rate, it is known that at high enough frequency, the law W equals Vk no longer holds. It's not exact at intermediate temperatures. Metals also have a term in the heat capacity that's proportional to T, so the overall heat capacity is C equals gamma T. I guess, dude. Okay, here's a chapter summary. Much of the heat capacity or specific heat of materials is due to atomic vibrations, yes. Boltzmann and Einstein models consider these vibrations as n-simple harmonic oscillators. Boltzmann classical analysis obtained the law of Dulong-Petit, C equals blah, 3R. Einstein quantum analysis shows that at temperatures below the oscillator frequency, degrees of freedom freeze out and heat capacity drops exponentially. Einstein frequency is a fitting parameter. Debye model treats oscillations as sound waves with no fitting parameters. W equals Vk, similar to light, but 3 polarizations, not 2. Quantization, similar to Planck's quantization of light. Maximum frequency cutoff, necessary to obtain a total of 3 n degrees of freedom. Obtains Dulong-Petit at a high T, and C is estimated to be T cubed at low T. Metals have an additional, albeit small, linear T term in the heat capacity. Druda theory. It shouldn't be so bad, because I already did some stuff in this, but I don't know. For now, we can leave this alone, I think. Might read it later, might not, I don't know. Should probably do the dishes, though. But yeah, I think that's about it for now. 2 hours knocked out. Technically an hour of studying, but god damn, my brain is not working right now. Well, it is, but I just feel exhausted. Like, I just feel tired. So it's not optimal. It's suboptimal learning, I'd say. But yeah. Whoosh. We'll catch you all in the next one for another good study session. Peace.